tonight's talk is all about Kotlin 2.0. How many of you have heard about Kotlin 2.0 or anything related to Kotlin, upcoming Kotlin changes? Great. So a few of us are active in following what's going on. As you might know, Kotlin 2.0 is coming soon. But let's start with how old Kotlin is now. Kotlin is almost, well, it is actually 13 years old now. It came out in July 13 years ago. I don't remember the exact date. But yeah, it is a teenager now. If you see a job listing which asks for 15 years of Kotlin experience, please flag that. You cannot have it, just saying. And you cannot really have more than 10 years of Kotlin experience unless you were working with JetBrains, because they took 2 years to release the first stable public available build. Anyway, Kotlin is 13 years old, and you know how 13-year-old teenagers are enthusiastic, have so much energy, and want to do so many things. And just like that, just like any good parent, JetBrains wants to support its teenager and expand its wings and achieve new things. And that's the motivation behind Kotlin 2.0. They want the language to evolve further. It has been evolving. We've seen so many new updates and so many new things coming through in Kotlin. The compiler, which was first developed and is still available as a public stable build, it enabled fast development, but it wasn't fast in itself. And we'll see a few reasons why it isn't very fast. It was never meant to be fast. It only wanted you to code quicker on the same JVM platform that you're used to. But just get your prototypes out quicker, or your production builds getting out quicker, so more agility to it. But now, as the Kotlin language is scaling, as we are seeing multi-platform support and multi-threading and all those fancy things, the compiler itself needs to keep up, and it needs to improve its internal data structures and stuff it uses to convert your human-readable code into machine-readable code. That was the motivation. Let's look at what a Kotlin compiler really does. And right now I'm going to talk about what they're doing with K2, which is the new compiler, and that's the name of the compiler. And then I'm going to slightly touch upon how it is different from Kotlin K1 compiler. If you think of the Kotlin compiler as a black box, this is roughly what it looks like. You have no idea what's going on inside the compiler, but it takes in source files and dependencies and compiler flags, and it gives out JVM class files or JavaScript files or native library SO bindings. But JetBrains has been kind enough in making it not so black boxed. They do call it this structure, rather. They call it as a more transparent box, and we'll see more transparency in the coming slides. The compiler itself is divided into two parts. And this is true for most language compilers out there, but my entire presentation is mostly based on Kotlin. There's this book called Dragon Book of Compilers, and the Kotlin teams really wants to be true to that book. Like, it has principles and theories and stuff which says a perfect compiler should look like this, a perfect language should look like this. In an ideal world, yes, we'll have that perfect language, but they're trying to achieve as close to as possible with that black Dragon book. So yeah, they're divided into two front ends and back ends. I'm sorry, there's one front end, and there are multiple kinds of back ends, and I'll talk about them more in a future slide. Front end takes the source code, dependency, flags, bring out something called program semantics, that goes into the back end, and then we get the JVM and stuff. Now, this front end and back end is not the HTML front end, back end we know, not the server side thing. It's completely different. It's just called front end and back end. Let's take a look at front end and dive into it. We know, obviously, it takes source code as an input, and it outputs something called front end intermediate representation. And all this process happens in stages, and it kind of looks like this. So the source code goes into a parser. Parser itself is divided into two parts. One is the lexer, which basically takes the language in a human-readable form and passes it through a grammar check of sorts. How in your languages and in English language, it's like there are rules and grammars around how you form sentences and stuff like that. Similar to that, any language has a grammar, right? And there's a massive difference between a human language versus a computer language, that if we get grammar wrong, like if I mess up some sort of word placement or punctuation or something, you still get the point I'm trying to make. Over here, however, the parser just says, nope, that's wrong. Let's fix it first. So this is where your compile time errors are first detected. And then the parser says, what's the point of sending anything forward all the way to backend when I know at this point this is wrong? It's very strict about it. Anyway, so once that is parsed, once the grammar is checked, it creates something called parse trees. Parse trees have tokens for things like, actually I should move to the next one. Parse trees it takes in the source code and converts it into a tree. It's a concrete syntax tree, which means no information from the source code, including useful and useless keywords, as well as white spaces. None of it is dropped. It's very concrete. What you write goes in. Even the comments are there, part of the tree. It makes it a very heavy tree. It's got details like it's a function call, then nodes for arguments, and then further nodes for the type reference of those arguments and things like that. But I'm not going to get into details of that. You can scan that QR code. There's a video behind it which explains, and it's directly from JetBrains. It explains how a parse tree in Kotlin K2 works. Anyway, so this parse tree, it goes into this tool called raw FIR builder, which is raw front-end builder. It further processes the incoming parse tree, and it generates a new tree called front-end intermediate representation. Now, it's an abstract syntax tree. An abstract syntax tree over here means that it will drop information which is useless for the compiler in the further stages. Things like keywords, which make sense to us but do not make sense to a compiler. Comments, completely discarded. White space, no longer needed, because now we grammatically know what the function is doing or what the program is doing. So all of that happens. It performs something called desugaring. And I'm going to touch upon desugaring in just a minute, because we all know Kotlin is heavy with syntactical sugar. It takes a lot of heavy lifting for us. It makes it easy to do a lot of things in 1 or 2 lines. So all of this needs to be, simplified for the compiler to process. So that's where the desugaring happens. Raw FIR breaks down that 1-line code into what it actually should have been if it was C++, and then kind of makes the compiler understand that this is what the programmer is trying to achieve. More information on the raw FIR and its structure and everything is on this video. It's the same video, just a different timestamp. These are all timestamp-based QRs, so you'll go to the exact same point in the video. But yeah, some of the easy to understand desugaring things are if conditions are converted into when, and this is a universal thing in Kotlin. When it comes to compiler, the compiler knows how to process a when statement, but does not know how to process an if statement. So all if statements are converted into when statements. This thing, for each loop of this sort, gets converted into a while loop with an iterator. I'm not sure how it manages complex conditions, but something simple like this, where it's just going through all the items in a list, this is how it goes. You would see that it's expanding the code, but this is what the compiler needs. It needs more verbosity in the code so that it knows exactly what to do and there's no ambiguity whatsoever. All the array index operators and things like that, they get converted into their respective operator functions. So yeah, just as an example, and this is what happens when you try to access or set a value to an array. And Kotlin has this destructuring syntax where a map, for example, gets destructured into 2 variables in 1 line, and you can declare them together. You don't have to do 2 different things. It gets desugared into this kind of construct over here on the right, where these hidden functions called component 1 and component 2 and so on and so forth, they can be accessed, and these values are then individually fed into the memory allocations. Just a brief overview of what desugaring really is. From here, once all of this is done, desugaring is done, the raw FIR is built by the compiler, it moves on to analyzer. And what an analyzer does is it adds semantic information to this abstract syntax tree of the FIR. And semantics basically means it figures out which import are we talking about. If there's a user-defined type, which is basically the same name as the Kotlin standard library name, this is the stage where it decides which one are we using. This is the smart part, and this is probably the most complicated part of the compiler, and even the slowest. So this had to be optimized. This is one of the most optimized pieces in the Kotlin compiler. So yeah, imports are resolved. All type references are resolved, where it figures out implicit and explicit ones. Explicit are easier because it's declared over there. Implicit, it needs to, go through all the call stack and then go as deep as it can to figure out the most explicit one and then come back. Oftentimes you might have seen code like fun xyz is equal to something. That's where the implicit type declaration happens, because it needs to figure out from the equal to right hand side to see what's the final data type that needs to be declared over here. So all these semantics, all of this information that compiler would need or hardware would need to run a program, all of that happens over here in the analyzer. It does a top-down body analysis, which means Kotlin, because it's not a functional programming, it goes through the top of the script all the way to the bottom of the script, and it just does all sorts of resolution of candidates, function overloading, and all of that. This is the brain of the compiler, where it's smart enough to figure out that your single line code needs to be this. This is exactly what you mean, and it's really, really efficient that way, especially in K2. Again, there is an in-depth explanation on how it modifies the FIR tree to store all of this information. Same video, different timestamp if you want to have a look. This modified modified FIR from the analyzer goes into this thing called checkers. Now, checkers what it does is it collects all the warnings and all the diagnostics out of this program and sends it back to the user. If you're using an ID, you'll get you get all the information in real time. If you're using terminal, you still get all the information. But this information is sort of carried forward as well, but it's mostly meant for the end programmer so that they can understand, well, you're probably using a deprecated function. It works, no problem, but maybe you should update it to the new one, which is XYZ. So yeah, this is where it happens. Diagnostic information. All right. Differences between K1 frontend and K2 frontend. K1 does not have the concept of FIR. It has something called, it uses the parser tree, where it uses the parser tree throughout the code execution, all the way till the end. And parse tree just contains the breakdown of the code. It does not have any semantic information. For semantic information, they have this massive map of maps called binding context. And there has to be a continuous lookup into the map and come back, and then look up into the map and come back. And this happens over and over and over again throughout the running of the program. So it increases the time it takes to figure out what the program is doing, and time it takes to figure out which memory allocation to use, what kind of reference is this one. And that was the reason for slowness. Well, it's not exactly slowness, but it's an opportunity for improvement for Kotlin. And that also creates another problem with the jump instruction. When you're trying to resolve a file or an import from a different file, because of how the PSI is structured and how the lookups are made, it has a lot of jump instruction at a bytecode level. But whereas with the FIR, because all of that is still part of the node in the tree, it doesn't have to jump in and out. It has resolved it all of it in the raw FIR builder, and now it has it all stored. So it makes it faster to run the program because all the information is available. Sure, it makes a slightly heavier tree, but then it's all there together, so it executes faster. And these days, most of our devices which are running Kotlin or JVM do not have a massive memory issue anymore. We've all got 16 GB RAMs and things like that, and if you're running it on servers, they've got massive amounts of RAM. So space is not really a concern anymore. It is, but not to a massive extent. And with these changes, with just the front end switched and back end still being the old one, the JetBrains team found that Kotlin is now running 3 times faster. So if your compilation of a program took 12 seconds, it's probably now going to take just 4 seconds, which is a step up, especially when it comes to Android development. We all have waited for an hour just for a program to compile, maybe more, and then there's a Zoom meeting, so everything slows down even further. All of this is hopefully going to get fixed. All right, so that was probably it for the front end. Let's talk about the back end. What back end does is it takes this front end intermediate representation, puts it through something called FIR to IR, and converts it into an intermediate representation. So this representation is different to the front end one. FIR is strictly meant for the front end part of the compiler. IR is strictly meant for the back end part of the compiler. Backend is able to perform further work on this IR. And again, high-level view of what it looks like is this. But a more detailed explanation would be this. This is a logical structure. So the FIR comes in, and then there's different kinds of backend these days for Kotlin. You know how Kotlin can run on web, Kotlin can do native libraries, Kotlin is trying to do WebAssembly as well. So to enable all of that to happen without having to compile it again and again for different ones, they created this concept of front-end representation and the conversion of FIR to IR. Now this FIR to IR, again, is common across all backends, but then the IR gets converted into individual platforms as required. The JVM backend knows how to convert it into a dot class. The JavaScript one knows how to convert it into JavaScript, and so on and so forth. So this is the optimized structure for the backend. However, with the motivation of backend includes sharing logic between multiple backends so that you write once, compile it once, and take it to different backends and just run it. Similar to what Java was trying to do when it came out. You write it once, you convert it into bytecode and put the bytecode in any hardware, it'll run. It wants to support new language features. If you follow the Kotlin development page on kotlinlang.org, you will see they've got a lot of ideas of how Kotlin can expand. And at this point, they're only focusing on Kotlin 2.0. They're not ruling out Kotlin 3.0, and they're not saying when it's going to happen, but it will happen, and they've got huge ideas for that. So if you do look at it, they ran a big survey recently with the developers of what they want to see in Kotlin as a language in the future. So yeah, they're all considering all of it. These changes are being made so that those massive changes are easier to make. Performance improvement of backend is not a goal at this time, and that is really important to understand. The only performance improvement is happening in front end. Backend is more or less still the same because the most important part is the converter and the optimizer, which takes in the intermediate representation, converts into dot class or JS or whatever. So that remains the same. It's just they want you to just not worry about the new compiler. Let's say the Kotlin compiler 2 comes out tomorrow. Your same code should just work. That's their idea. It should just compile faster and work. That's why they're calling it backwards compatible. They're not forcing you to change your code significantly or they just don't want you to change your code. They just want to be there at the back of your code supporting better performance. And they want people to be able to develop compiler plugins. So that has been happening for the front end, but because backend did not have a unique way of representing code so far, it wasn't happening. Now that we have IR for backend as well, People can write optimizers and plugins for backend as well. Backend K2 versus K1. K1 still uses that parser tree, that interface that we saw in front end, and the same massive maps of maps for semantic information. So it makes it slow, makes it jump from here to there and figure out information. K2 backend has IR, which has all the information in the node that the converter would ever need. The JVM and JS backends, when Kotlin first launched, were very different to what they are now. At that time, they just wanted to get faster development done. And right now, with the multi-platform approach in mind, they want to be able to write optimized code and efficient code for all platforms. And with this K2 backend and the new intermediate representation, they're able to create a brand new backend, which did not exist until recently, which is the native backend. So you can write your Kotlin code. It will compile into native libraries for, let's say, Windows or Linux machine or Apple M1 or Apple Intel. All of that can be done with the new backend structure, a new structure of the compiler here. Some more details. It's a different video this time, but some more details on exactly how the tree of the IR and everything looks can be found on this, if you scan this QR. And then further readings on Kotlin K1, K2 can be found here. I'll be publishing my slides. All of these are clickable URLs. Some of them are videos, some of them are articles. But yeah, I'll publish that and you can check them out. There was supposed to be a break now, but we've all had a long break. But before we'll take a small break anyway. It's fine. But before we do that, I do have some swag to give away. Desh has got them, and I have questions so that you get swag. So first question. It'll be nice if you keep your phones down and not Google the answers. What was the project name for Kotlin when they actually started 13 years ago? Huh? No, I mean, take a wild guess. There's wrong answers, obviously, and it's a hard question. Can't hear you. The name of Kotlin before Kotlin was the public name. Yeah, that was going to be my second question, but okay. Please give him a round of applause. So what he said was, yeah. I'll change that. I've got questions. What he said was the name of Kotlin comes from this island near St. Petersburg. It's called Kotlin Island. And St. Petersburg is where JetBrains as a company is registered, and apparently it's just a 32-minute drive away, which is nice. So that's the inspiration for Kotlin as a name. Back to my original question, what was the project name, and still is the project name? And if you've been curious enough to look into the .idea folder and see all the ID bindings, you will find the name. It's still being used heavily. Take a wild guess. All right, hint. Okay, wrong. It's not Lombok. Okay, let me give you a hint. It's related to JetBrains. Close. You're halfway there. Nah. All right, 3 more guesses and then I'll tell you the answer. Jetpack, nope. No, not jet lag. You were very close though. You were just one character away. It's jet lang. Yeah. Just for being super duper close, let's give him a gift as well. All right. There's an official mascot for Kotlin as a language. It looks like a K, of course. It's there as well, but it has eyes. It's there on my last slide as well. Not asking anyone to draw it or think of it, but if you can guess the name of that mascot. Nope, not panda. No. It's got nothing to do with animals. It's on my last slide. I'll show it later. All right. Cody, yep, that's right. Perfect. It's all right. Rules are meant to be broken. Okay, one more question. Let me think of another question. Can't think of more questions. I came prepared with a lot of questions. I should have written them down. All right, if I do think of something, I'll ask after the break. But for now, maybe take a 5-minute break, and then we look into what's there in Kotlin language 2.0. Full disclosure, it's not really new things in the language, it's just incremental changes, but they will be stable by the time Kotlin 2.0 is out. So yeah, let's take a 5-minute break and come back at 7:10. Okay, welcome back. Are we pumped? No, that's fine. It's late in the evening. Okay, carrying on then. We're going to look at what's new in Kotlin as a language. Again, full disclosure, these features, these language constructs are already there. Some of them are stable, some of them are experimental. But the idea is all of this is made possible because they're making a new backend. So it'll be more optimized, it'll be faster when the new backend is out. As well as the fact that these will be stable enough for them to build more constructs on top of these concepts. I'm going to talk about just 4 very basic ones. There are a few more in experimental stage. And to be honest, I completed my content today while sitting there at 4:30 p.m. So I didn't have time to go through all of them and do it. But yeah, hopefully this helps people. So yeah, what's new? But what's new for developers? People like us who, in most cases, don't really care about the compiler. Only when there's something new and it's faster, we care about it. These are the 4 things that I could quickly go through, understand, create a very tiny demo for. Entry property of enum classes, data objects, range until operator, and secondary constructors for inline value classes. Long words, heavy words, let's see what they are. You know how enums have a values function? JetBrains wants you to use the entries property now, and they have a reason behind it. They're not going to remove values function completely. It's still going to be there. However, if you start targeting Kotlin 1.9, which came out earlier this month, or Kotlin 2, your ID is going to tell you, and this is the checker doing its thing, it's going to tell you that, well, there's something new and better available which you can use. And that's the entry properties. And what is it? It's a pre-allocated memory which has all the defined enum constants as a list, as an immutable list to be precise. You can't change it. When you access values function, you get an array of those objects which is mutable. So there is a reason, or there is a way for you to introduce a bug if you were using values function. But with entries, you can't really do that. You can still do the same things that you would do because it's still a collection. So all your collections still work, or your collection operations still work. An example of enum class with how you would access the values function. Just imagine that you had some operators on that output of color.values at the bottom. Now, to be able to use this new construct, all you have to do is get rid of values and just put entries over there. That's it. Everything else works the same. But there's almost no chance of you messing up that entries list because it's immutable. You can't edit it, and it's a list, so it's a stronger collection for Kotlin. Next up is data objects. We all know what data classes are. If you don't know, that's fine. Data classes are classes specifically meant to hold data. They won't have a lot of logic attached to them. They make excellent replacement for plain old Java objects, which just parse network data and store it while you're doing it. Data objects are basically something similar, but they're similar to what a pure singleton object would be. There would be one and only one instance per session of a running program, and they'll be shared across the entire program. The compiler generates the toString, equals, and hash code functions for the data objects. If you were using just plain object, none of these would be available. And on top of that, you cannot override these toString or these generated functions. You can do that in data classes, but you can't over here because it's just a compiler created memory allocation. You don't have mutability on it. No copier component function available because it doesn't make sense. It's a singleton, so you can't copy it. It doesn't have its own properties, so there's no point of getting components. Whereas in data classes, you can copy the object. It's a class, you can create an object, you can copy it, you can access its components. Classic example, you've got a sealed interface called direction. You can have an object or a data object. Just an example over here of what I'm going to show you in the demo just in a bit. Okay, next up, range until operator. It's a new operator that is being added for open-ended ranges. How do I summarize? It's to have inclusive ranges both on left and right hand side. It'll do the step counting and everything for you. Up until now, you could use the until function, but there was always a confusion whether the upper limit is inclusive or not. Like, what does it mean? Does it go from 2 till 9, or does it go from 2 till 10? With this operator, it knows that it'll always be under 10. It will not be 10. So it makes it clearer. Internally, it'll still ultimately call the until operator, which will get resolved into the until function and so on and so forth, but it's an easier construct. This is another good example of syntactical sugar. All of this gets desugared at the raw FIR builder stage. Inline value classes are now getting secondary constructor support. Let me take a wild poll here. Do you know what inline value classes are? Raise your hands if you do know. Okay, one person knows. All right, let me explain inline value classes first then. Inline classes are basically a way of writing code quickly, but they're never really classes in themselves. When the code is run and compiled, they get the class constructor gets replaced with the actual definition of the class. So let me jump to an example. Yeah, this value class, country, etc. If you were to access country Australia as a constructor in your code, when it gets compiled at the FIR stage, it will get replaced with the definition of the entire class. So it saves the overhead of saving the class definition in the memory. Instead, it just creates a real-time object. That's what inline constructors are, and inline classes are. They're called value classes in Kotlin. And if you want to make them inline in Java virtual machine as well, you just have to add that annotation. Up until now, up until 1.8.20, I think, inline classes can have one constructor only. Actually, inline classes need to have one constructor. You cannot have an empty constructor inline class. But with the upcoming 1.9 release and so on, in the future, you can have multiple parameters in secondary constructors. You still need that primary constructor with one parameter, but you can now individually access each parameter, and you can write your checks for parameters because you know the entire class is going to get dumped into the point of construction. So it's best to use these individual checks and whatever. So this is how it was up until now. This is what you can do going forward. You can create a secondary constructor, and the way Kotlin works is you still have to call the primary constructor from the secondary constructor. This example just takes that name and passes it to the primary constructor. The example on docs and a few videos that I've referenced later what they do is they concatenate name and capital city, or the two parameters of the secondary constructor, into one and pass it to the primary constructor. And then in the primary constructor, you can have argument checks and whatever is your requirement for those. What does Kotlin 2.0 mean for Android? There is experimental support for Kotlin 2.0 in Android Studio already. If you're using Giraffe 223 builds or Hedgehog 231 builds, you can use Kotlin 2.0 as an experimental compiler already. It'll compile and work, and you can figure out any bugs or anything with the compiler. What Kotlin and JetBrains are saying is that for most part it should work, but there would be bugs in the compiler itself. So just use it, try it, report it to us, and we'll try to fix it. Then they will not force you to rewrite your code just to make Kotlin 2.0 work. Kotlin symbol processing, Jetpack Compose, even regular Compose, and on Android Studio, they're all working. The individual teams are working into getting these compiler plugins and this support as stable. It's not going to happen anytime soon, because 2.0 as a beta has just been released, which means it'll be another half a year at least before 2.0 becomes stable, which means another half a year from then before Google makes its changes. Also for multi-platform, there's some changes that is happening where Kotlin DSL will be replaced by a new DSL being created by Google just for the Android targets. Other targets remain unaffected for now. So all of that is going to take time, and it's going to trickle down by July next year, hopefully. But yeah, it's good to get ahead, try things out, be ready for what could happen. Because K2 is in beta now, it's not going to change drastically. If anything, it'll be more performance optimizations. To try Kotlin 2.0 in your Android projects today, if you're using Kotlin DSL, this is the thing you need to put in your module level build.gradle file. And something similar if you're using the Groovy-based DSL. I think doesn't change much. It's pretty much the same. But yeah, just declare 2.0 as a language version, and it will start using the new compiler in beta. You can't use it in, Giraffe is now in stable. So yeah, you can use it in Giraffe 223 stable and Hedgehog Canary builds. If you were to use just Kotlin 2.0 standalone on IntelliJ using Gradle builds, you just have to either add this line in Gradle properties, or if you're compiling from the terminal using Gradle wrappers, you just have to pass this flag, and it will compile it against the beta compiler instead of the new or the old compiler. And as usual, Kotlin says, try it out. You will find bugs in our compiler. Please report it to us, and we'll try our best to fix them. Excuse me. I think that's pretty much it for my language construct part. Further readings are over here. The first and the last one are videos, and the middle one is just the reference to the video as docs. That was faster than I thought. I thought it'll take more than 1.5 hours, but we're at the end of it. This entire slide deck is now published on my website. If you go to website, there's this talks page, in the first talk in the list of talks has this slide deck, and yeah, you can access it. You can get the links and everything, and that's Cody. That is Cody. Now you know. Okay. Can we switch back to my computer, please? And I'm gonna do some demos. Again, like I said, these were quickly created just a few hours ago. So, all right, data objects. Why is this here? This should not be here. Data objects. Now, as shown, this is visible to everyone, right? Do I need to increase the font size? Is it good? Okay, perfect. So yeah, I've got the sealed interface direction, and I've got both data objects and regular objects. North and east are regular objects, and this piece of code is targeting Kotlin 1.9. That's why I'm getting this this warning from the checker saying sealed sub object can be converted into a data object. It's just a suggestion. It's not forcing me. It's not an error. If it was an error, it would stop at the parser level. Anyway, just to highlight how toString and everything generation works, I'm going to run this code. Now each of these objects is just calling its toString function. You can see it's not declared anywhere, so you can notice the difference, and you'll see how compiler or how the data keyword over here makes a difference. So with north and east being regular objects, it's taking the name of the object and then printing out the hash code of that object. But with south and west being data objects, it has created the toString function, which is just the name. There is a separate hash code function. There's a separate what's it called? Equals function as well, which will do all the comparisons and everything for you. But yeah, just a quick demonstration that this is how I haven't written any separate code. This is compiler doing its things, and this is still running K1 compiler, by the way. I haven't set K2 compiler flags. Okay, enum entries. Again, because I'm targeting Kotlin 1.9, I get this nice little suggestion saying values is recommended to be replaced by entries since 1.9. And then there's a help of button over here which does it for me, but I don't have to. Okay. Sorry, wrong file. With color.values, because it's an array, and array doesn't have a concrete definition of toString, it uses the JVM name lcolor. All JVM names start with L. I don't know why. And then the hash code of the list, the array. Whereas with the second one, because it's a proper list with defined names and everything, and it's a immutable list, red, orange, yellow, which is the name of the items defined in the enum class, that gets printed out. Now I can perform any kind of collection operations on this. I could map it to something. Whatever you could do with values, you could do over here as well. Next one is inline class. Okay, so I've got two inline classes with the same name. The second one is commented out right now because Kotlin will complain two classes with same name otherwise. Okay, so this one's got just one parameter. This is what is normal right now, and if I run it, it just prints out Australia created because I'm passing the name as Australia over here. Now if I were to comment out the first definition of the class and bring in the second one, now both of them are pointing to the same new class, which has the primary constructor over here. There's a secondary constructor which takes in 2 arguments and prints the name of the capital city. Okay, quick question. Can anybody take a wild guess of what the output would be here? We've already seen the output for the previous one, which was Australia created. What would be the output of the second one? That's partially okay. First Australia created, then Canberra created. It's partially correct. I'd say 2/3 correct.
Double Australia created.
Correct. Yes. So it'll be Australia created first because in the first one we don't have. We're not calling the second constructor at all. We're just calling the first one. Whereas the second one we'll call the secondary constructor, which calls the first constructor first. Remember, super types are always created first, and then the second println gets called. Australia created, which is from the first object. Australia created and Canberra created from the second one. I think the spelling of Canberra is wrong, or is it correct? I don't know. Correct? Okay. Yay. Yeah, that's all I had for the demos. I had one more question to give away another swag. Does anyone know before interface as a keyword was used in Kotlin, what were interfaces called? Hmm? No, they are not called mixins. um,
Virtual function?
no, no. Abstract classes are different. Uh, if you've been working with Kotlin for 13 years, you would know. Or if you were Googling like me for some Kotlin trivia. Huh?
Can you give a hint?
Okay, let me think of what hint I can give. Can't think of a hint right now. No, really can't think of a hint right now. Okay, just take wild guesses, I guess. What could be a good hint for this? No, it's not. It's not Swift or Objective C. It's not struct. It's it's nothing that any other language has ever used. Or maybe they have, I just don't know about it, but not the common languages like C, C++. It's not struct. Three more guesses and then I'll give the answer away, and whoever is closest gets a pair of socks. Huh?
Callbacks, delegates?
Nope. I'll take that as one guess to give more opportunities.
It could be a part of Kotlin.
No, it's not part of Kotlin. Not the word Kotlin, no. Not even Jetlang. No, it's not expect. Blueprint. You close. So maybe he gets the socks. The word is actually trait. 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 Yeah. I don't know if any other language uses the word trait for interfaces, but before Kotlin became a public language, it was